Hi, everyone, and thank you for joining us for the Data Architecture Virtual Group meeting for April 2019. My name is Kenny Neal, and I'm one of the co-leaders of the virtual group. Today, Jonathan Kehayias is here to talk to us about going asynchronous with Service Broker. We're very happy to have him. Let me go back to the screen. You can reach me or my partner Rob on Twitter at those two Twitter IDs, or you can email rob at SQLtigers.com. Some upcoming meetings in May. We've got Mark Vanderwild coming back, talking about building a data lake on ADLS, and Glenn Berry in July. We've got a couple more that we're trying to get lined up. As soon as we get that ironed out, I'll send out an email to everyone. We have two sponsors again. We're very happy to have Nutanix back again as a sponsor, and also a big thank you to HBR for sponsoring us again this year. If you get the opportunity, thank them for supporting our group. They help us do a lot of the things that we do. PASS Summit 2019, the pre-cons have been announced and registration is open. If you've never been to PASS Summit, it's really something else. It's one of the best conferences you can go to for SQL related things. If you want some special access and you're a blogger, you can register for the Summit Blogger Program. That's a new thing, I think, this year. You can get some more information at that URL down below. You've got until April 25th to get signed up for that. We are one of several virtual groups. You can find a virtual group on just about any topic and in multiple languages. Here are some of the upcoming ones in the next month or so. Go to the pass.org website and you can get a complete list of everything and register for anything you'd like to see. And with that, I've churned through my past provided deck, so I'm going to change it over and hand it over to Jonathan. Jonathan, thank you very much again for joining us today.
Sure.
Here we go.
So let me share my screen. So this is going asynchronous with Service Broker. My name is Jonathan Kehayias. I'm a principal consultant with SQL Skills. I always say probably the most important thing on any of these slides is my email address. If you have a question related to Service Broker or something that I talk about, feel free to send me an email, jonathan@sqlskills.com. I'm on Twitter, although I'm not as active as I used to be. I'm on there as SQL Pool Boy. If you think that's a funny name, it really is. It's a bad joke that ended up published in a book, unfortunately, and I've kind of been stuck with it for the last 9 years. I do blog on SQLskills.com, and I've been thankfully recognized as a Microsoft Data Platform MVP for the last 11 years for SQL Server. So I do work with SQL Skills. Our team is a group of 6 consultants and trainers, Paul, Kimberly, Glenn, Aaron, myself, and Tim. We teach a lot of different instructor-led training. We do online training with Pluralsight. We offer consulting services for health checks, HADR strategy build-outs, hardware updates, performance tuning, various upgrades. We offer remote DBA services as well. We also speak at various conferences. I'll be doing a pre-conference session at PASS Summit. I believe Aaron was also selected as a pre-con instructor. And then the rest of our team will be at SQL Intersection. And if you're interested in knowing, more about what's going on with SQL Skills or interesting things upcoming with SQL Server, things we've seen, consulting, interesting, what we call curious cases, you can join our insider newsletter that goes out once every 2 weeks. We have a number of classes coming up, actually, at the end of this month and the beginning of May in Chicago. Anything from our 2 performance tuning classes, our accidental or junior DBA class, which is 3 days, our Azure class that Tim teaches, which is a really good class on Azure SQL Database, Azure Virtual Machine, and Azure Managed Instances for SQL Server. Power BI class, an upgrade class that's taught by Glenn and Tim. I teach a 2-day clustering and availability group class that covers the essentials of failover clustered instances and availability groups all the way through SQL 2019 new features and enhancements, including Linux. And then we have our practical machine learning class taught by Rafal as well. So Paul offers this every time we do an online user group session. If you email him, paul@sqlskills.com, with the subject line user group Pluralsight code, you'll get free access to the SQL Skills content that we've recorded on Pluralsight. There's over 145 hours of SQL Server content that's available there, including Paul's 7-hour logging, recovery, and transaction log course, his 4.5-hour weights course on weights, latches, and spin locks, and Kimberly's 7-hour optimizing stored procedure performance course. So what we're going to talk about in this session is Service Broker and the different use cases and some basic architectures for it. I always say that Service Broker is probably one of the best hidden gems inside a SQL Server for a lot of different reasons. And the biggest challenge with Service Broker is kind of getting the base knowledge and the architecture off the ground more than anything else, because there's very little UI support, even in the latest releases of Management Studio, for anything Service Broker related. You really have to go to DDL scripts. And as a part of the session, I'll provide the demos that we go through that build a very basic single database Service Broker implementation for executing tasks asynchronously inside of the engine and offloading some of that work away from the end user experience within the UI. So we're going to talk about different usage scenarios that Service Broker has, some of the advantages of utilizing Service Broker inside of SQL Server, and then the basic architecture and how you can automate some background task processing or asynchronous processing within a single database. So there's a lot of use cases for Service Broker. It can do a lot of different things. Anything from centralized data collection, where you have multiple sites processing transactions and they send that information to a centralized location for data storage or reporting purposes. That's really useful where you might have connections over the WAN between different sites, and the asynchronous message delivery for Service Broker's implementation actually allows anything locally to happen, even if you lose connectivity back to that central data store. And the messages are guaranteed to eventually be delivered if the connectivity issue is resolved or whatever communication issue is happening between the sites. Those messages are permed in that local database in the transmission queue, and it will retry delivery of those messages every 60 seconds until either the conversation dialog times out or you clear it, or it's successfully delivered. One of my favorite places for using Service Broker is, what I call asynchronous trigger execution, or asynchronous background processing in SQL Server. And I first implemented this to replace really complex logic that a customer had implemented inside of DML triggers that were really affecting their OLTP transaction performance. And I've used asynchronous execution for a lot of different things. Anywhere that there's a long-running task that would affect the end user experience, we can simply queue a message requesting a implementation of work to Service Broker and offload that logic into a separate transaction that's going to run as a background task on the server. And it guarantees that no matter what the end user does, that operation will complete. One of my customers had a task that would repost a lot of data in their system, and it would take upwards of 30 to 45 minutes to finish that processing. And they originally implemented it as their database was really small and their workload was much smaller, as a part of their web application. And the web application would provide basically like a spinning arrow that said that it was processing, and it would just sit and wait and wait and wait. And one of the problems they ran into was, as this started to take longer and longer, if somebody browsed away from that page, they closed their browser, they rebooted their machine, that long-running operation would then go into a rollback because the session would be terminated, the transaction would be open, and it would have to undo all of that work, and then somebody would have to come back in and then do it again. So by queuing that as a request into Service Broker, it actually guarantees that that operation will complete even if SQL Server restarts or the database has some kind of a crash, because it's going to go back through crash recovery, and that message will be re-queued back on the queue. The queue processor will pick it back up, and it will begin executing that task again. Another use case is for reliable processing of queries. And I actually implemented this with a customer that provides basically an online data warehouse of all kinds of different weather information across the United States, I believe Canada and Mexico at this point. But one of their challenges was handling end user requests that would pull that data, and at different times of the month they would have huge peaks in their workload that would saturate the server, and at times if they had an outage they would lose any of the requests that were already in process. So what they do now is they actually queue those requests into Service Broker, and Service Broker has a maximum number of queue workers that can be activated, and they will process each message in the order that was received. And if there's a failure of their service or database or anything else, those transactions roll back, return the message to the queue, and they'll restart processing after recovery. And then there's another task that actually notifies a requester when their request has been executed and is ready for delivery, and provides them a download link for the data that they wanted to pull out. There's also distributed server-side processing. If you have really large, complex systems that have different processing points in the application, you can transmit messages between them and request different units of work and give status updates between them. And probably the biggest advantage to Service Broker over a lot of the other queuing technologies that are out there, and I get this question all the time, how does it compare to MSMQ or some of these other services that are available? The biggest advantage is that it's integrated right in the database. So there's no overhead for managing distributed transactions. There's no, reconciliation process that has to happen between the message store and the transactional database if there's a need to restore one or the other of them. And it preserves the order of messages. So messages are received once and only once in the exact order that they were sent within a conversation handle. So it guarantees that order of operations is preserved across messages within the same conversation or dialogue. Now, another advantage for Service Broker is that there's locking internally with a special Service Broker type of lock that prevents out-of-order message processing when you have concurrent threads processing messages off of a queue. So anytime that a individual conversation is locked, the entire group of message related to that conversation is actually going to be locked. And this allows different threads to process concurrent conversation groups and allow for higher scalability and performance. It also allows loose coupling of your applications. So the sender of a message and the target of that message don't both have to be online. If it can't send the message, it queues it locally into the local database that's opening that conversation, and it retries. So this provides a lot of scheduling flexibility for outages and maintenance. You don't have to consider where things are coming from to take a target system down. You can actually allow those to continue to queue locally, take a server down, do whatever maintenance you need. When you bring it back up, those queues will deliver those messages and continue processing just as if there had not been an outage. There's just kind of a delay there. So the other thing that you can do is allow or disallow queue activation during peak load times, so that you can basically reduce the background processing or scale it up when there's more resources available to allow more throughput to happen as a part of the application architecture. And then the last advantage would be the fact that it allows automated activation or automated processing of the queues, and it allows concurrent parallel tasks to be executing against each of your queues within the definition of the activation process to scale out and match the volume of messages that are coming into any queue. You can run programs inside of the database. Usually that's just a stored procedure that's bound to the queue for automated processing. Or you can run external applications if you have a really complex set of rules or processes that need to run and they've already been implemented. The external activator feature in the feature pack for SQL Server can be configured to allow that task or that application to execute, and it can process the queued messages and do whatever service work is needed as well. So there's a number of features in SQL Server that are actually built on top of Service Broker. Event notifications that watch for trace and DDL events are built entirely on top of the Service Broker feature for SQL Server. In fact, that's the first place that I ever worked with Service Broker, was event notifications and having automated emails sent to me by database mail anytime blocking exceeded a certain threshold and the block process report generated. Errors of a severity higher than 10 were generated inside of the instance so that I got an email immediately to notify me, or deadlock graphs as well. The query notification feature in SQL Server that monitors changes for results is actually leveraged through, external queue activation of Service Broker. When you enlist a SQL dependency in a .NET application, that's leveraging query notifications, and that's actually building internal Service Broker components to process that query notification of change back to the application. It's used a lot of times when you're queuing data that doesn't change very frequently to let the application know to, caching data that doesn't change very frequently to let the application know it needs to go refresh that cache. The database mail feature is actually an externally activated executable application that monitors for messages being queued inside of MSDB when you call sp_send_db mail. And then the last feature is WMI events, which piggyback on the event notification infrastructure for integration with Windows Management Instrumentation, or WMI, inside of Windows. Now, the basic architecture for Service Broker can be implemented entirely inside of a single database. And there's a few things terminology-wise that are very specific to Service Broker. One of them being the terms target and initiator. So within the Service Broker architecture, and pretty much every example you'll find online, implements the target and the initiator as separate entities, and it's not necessary within Service Broker. A lot of the architectures that I design, depending on what I need it to do, actually leverage a single queue and a single service as both the target and the initiator. The target is who you're sending a message to. The initiator is who's sending it. So for basic asynchronous task processing, you can have it send to itself and then process the message automatically, just to reduce the number of objects that are in the system. But a lot of times when you look at the basic architectures that are in demos, you're going to see a separate initiator service and queue and a target service and queue. And I'll show those as a part of the demos and the way that you would architect it with just a single queue and service as well. So this is a lot of times how I implement asynchronous processing. I want to decouple something from the application and ensure that it runs inside of SQL Server, and I'm going to implement it as a background task. I also do this anywhere that I want to do parallel processing of something that might take a long time inside of SQL Server. The caveat being, be careful how many concurrent threads you allow to execute. You don't want to exceed the number of schedulers available inside of SQL Server for concurrent threads. A lot of times, you'll even want to be lower than that, because Service Broker can absolutely tax a system to 100% CPU if you provided the right workload and you have a right number of concurrent threads processing. So the first step you need to do is enable the database for Service Broker. There's a number of different ways to do this. Alter database, enable broker is the command that you would use. The caveat there is it has to be in single user mode when you enable Service Broker. You can also execute a command, alter database and set new broker. And what that does is it changes the Service Broker GUID inside of the database and activates it for Service Broker. But again, that requires the database to be in single user mode. Where that becomes a challenge is customers that have implemented availability groups for a database. And if a database is participating in an availability group, there's no way for you to put it into single user mode without taking it out of the availability group. So it's possible to remove a database from an availability group, enable Service Broker, and then join it back to the availability group without having to resync all of the replicas. When you take the database out of the availability group, all the secondaries go into a restoring mode. And as long as there's not a transaction log backup between removing the database and joining it back into the availability group appropriately, it will automatically resync and transmit any transactional change data that has happened from the time that it was taken out of the availability group. So there's just a few extra steps that have to be done there to be able to get an availability database into single user mode, but it's possible. So for the basic architecture, we need to define message types, and message types are basically the message that we're going to send to Service Broker and queue requesting a type of operation. We need to create a contract that defines which messages are going to be sent by the initiator, and then whether or not the target is allowed to reply with a specific message type or not. And then we need to create our queue and services that actually store and allow access to the information. So when we create a target service or a service that we're going to send a message to start a conversation, you have to specify a contract. If you don't, you cannot send messages or start a new conversation from any other service to that service. If you're separating target and initiator services, you can create the initiator service with no contract. That just means nobody can send a message to it, but it can be used to send messages to other services. It's kind of confusing, I know. But there are cases where you have something that you don't want to be able to be targeted by any message type at all. And that's where you would separate the services out and define a service with no contract at all. So the 4 basic types of objects that you need with Service Broker are your message types, a contract that defines which messages go between which services, a queue for queues for storing the data, which are implemented as internal tables, and then the service, which is basically the business unit of work that's going to be executed, and services are bound onto our queues. So our message types really just define the name and type of data that's going to be contained in a message. SQL Server can do different validation of message types for you depending on what you configure the message type as. There's a question that somebody says, is it available in Azure SQL database? And my answer to that is I need to double check, but no. It's not available in Azure SQL database because Service Broker has its own networking components that cross instance boundaries for some configurations. So even I don't know why the single database configuration isn't possible, but the last time I looked, nothing Service Broker related was supported by Azure SQL database. You can do it between Azure virtual machines, and I'm pretty sure there's a limitation on managed instances because they don't allow certain things to go outside of the network boundary. But I would have to check for that as well. If If you send me an email, Mikhail, I'll happily give you the references back by link, but I'm pretty sure that it's not available anywhere but Azure Virtual Machine. So as a part of the message definition, you can define that SQL Server validates the message has valid XML, XML conforming to a schema, or no data at all. You can also tell SQL Server to do no message validation. And that basically allows Service Broker to accept any kind of data, including binary data, XML, or an empty message. And then it's up to your application to properly handle that message format. There are system message types that exist. Those exist primarily for handling errors, dialog status. And if you don't specify a message type when you send a message, the default message type is going to be used within the system because it has to apply something to it. So my machine's frozen. Contracts. Within Service Broker, contracts basically just define what messages are going to be used for specific tasks. They're an agreement between the services that implement the contract about what type of message each of them will send for a given task. They have to contain a message type to be sent by an initiator. Otherwise, there's no way for a conversation to begin. You can create a contract that says the initiator sends the hello world message type, and the target responds or can send back, if it needs to, a hello back message type, or the target doesn't have to send anything back. It all just depends on the implementation of what you're trying to accomplish within Service Broker. Radu just asked, does validation of the message affect performance? Yes. Validating XML can absolutely affect performance. In fact, if you look at the SQL Cat team's articles on Service Broker performance, one of their recommendations is production environments disable validation of XML and set validation to none so that it just allows wide open throughput. One of the challenges there, though, is if you get malformed XML, you'll end up with a queue deactivation happening due to what's known as a poison message. But hopefully you're testing everything before it goes in. If we have a use case to replicate data from an OLTP server to a reporting server with almost real time as a requirement, would Service Broker be a solution? No. It could be. It would be really challenging to implement. Availability groups typically are the solution there. Transactional replication would be the next thing that I would recommend. Making Service Broker perform the functionality of replication would be a lot of work. Armando asked, this would break the transaction in two, losing atomicity, wouldn't it? I'm not sure what you're asking. Can you be more specific on that? And I'll answer that. It depends on what you're referring to there. So our third broker component would be queues, and our queues are what store messages. So they're implemented internally in the database as an internal table. They are bound to, our services are bound to our queues, and anytime a message arrives at a service, it's inserted into the queue associated with that service. And then each row in the queue contains a number of identifying things. First, it has the contents of the message type, and any validation that was performed. It tells where the message came from and where the message was targeted to, what contract it belonged to, the conversation handle, which is a unique identifier associated with that conversation, and then some internal queue information that includes the queuing order so that you can see the order that messages were sent between services and arrived on the queue. Now, for application implementation, the applications you design on Service Broker have to use a DML command called receive to pop the message off the queue or remove the dequeue the message for processing. You can select against a queue and view the status, but it doesn't remove anything from the queue when you do that. All the messages in a individual conversation or group of conversations can be removed simultaneously for processing by an application. There's a means of doing that for batch processing, utilizing either a cursor or a application level loop if you're doing external activation. And if you do row by row processing, the queue will return the messages in the order the messages were sent. If you're doing a kind of a global receive by the application and retrieving multiple messages, that's where you need to utilize the queue order in the application to ensure that your application then processes those messages in the appropriate order. You can use the store procedure for internal activation. Within a queue, you basically bind the queue to a stored procedure, and that stored procedure has all of your activation logic built into it. Now, services within Service Broker are basically the name of a business operation or a task that's being implemented. If you look at different examples online, a lot of times they use a fully qualified URL as a service name, and that's not a requirement. Usually I name a service directly for whatever task it does. The name of the service is used for delivery of messages to the correct queue inside of a database. They can also be used for routing purposes from the target to the initiator and back. My recommendation would be not to rely on the service name as your routing mechanism, though. You want to explicitly define your routes using the create route DDL if you're crossing instance boundaries for a lot of different reasons. If you rely on the service name for route delivery and you have something that changes, you have to go redeploy the services and update a number of things. It's a lot easier to just change the route information in MSDB and the local database when that happens, because you don't have to drop services or in some cases requeue messages because they're stuck in the transmission queue and aren't going to be delivered the way that they were originally sent. Every service is bound to a specific queue for storing its incoming messages. Once the message arrives at the service, it immediately goes on the queue, and it will stay there until it's processed by your application. So let's look at a basic architecture or the basic component setup for Service Broker. So we're going to create a database called Single DB Broker. We're going to enable that database for Service Broker. And then we're going to create two message types, one a request message and the other a reply message. And they're both going to validate that they're sending or receiving well-formed XML as a part of that message. You don't have to do XML. You can send strings as long as your application knows the data type that's coming through. Within Service Broker itself, everything is stored in a var binary value or format. So you cast the value to whatever you need it to be. Even though we're sending XML, when we process the message, we have to cast that binary value stored in the queue back into XML to be able to process the message. Otherwise, it just comes back out as binary. So if we look at our message types, anything less than 65,535 is going to be our user-defined messages. Everything above will be our system-defined messages. So here's the two messages that we created. They're both going to validate XML. And these are our system message types. For errors in Dialog, we're going to talk about shortly. Query notifications, event notifications. Dialog timers are useful for implementing a delay or for causing certain operations to happen within a set period of time. And what happens when that dialog timer fires is it generates an event with this message type, and you can then clean things up or cause certain processes to actually happen as a part of your application design. The configuration service is a more advanced topic for Service Broker that allows you to have a central server that is the repository for all configuration information related to Service Broker in a larger topology or larger implementation. And if there's a missing route or it can't determine where to send a message, it will communicate to that configuration service and bring back the DDL to be able to automatically update its configuration and correct missing routes or missing service bindings or failed service bindings between services to allow message delivery to basically self-recover, but it requires a decent amount of configuration to get that working. And then the service diagnostic and echo messages are used by Service Broker for diagnostics and the SSB diagnose tool. We're going to create a contract called sample contract that specifies our request message is sent by the initiator service and our reply message will be sent back by the target service. And if we look at our contracts, again, everything above 65,535 is going to be a system contract, and those are for event notifications, query notifications, the configuration notice, and then the diagnostic and echoes contracts. We're going to create a target queue for storing the messages we send. If we look at our queues, every database is going to have queues defined in it for query notifications, event notifications, and then just a basic Service Broker queue. But this is our user queue that we just created. We're going to create a service on top of our queue, and that service is going to be our target service. We could name it anything we want. If it was a credit card processing service, we could call it credit card processor. It's going to store messages to our target queue, and then it's going to implement our sample contract, which allows our target service to receive those messages or to be have messages sent to it with a type of request message. If we look at our services, here's our user service, and then our system services for event notifications, query notifications, and just Service Broker itself. And then we're going to set up the initiator side. So we're going to create an initiator queue and create our initiator service. And there's no contract specified here, which means you can't send a message to the initiator service starting a new conversation. It can only receive messages that come from someplace it's already sent a message to. So that's our basic architecture. It's really very simple, just a few components that need to be configured. And the Service Broker architecture set up. Now we have to actually create conversations or create what's known as a dialogue to begin the persisted stream of messages between our two services. So dialogues are implemented in what's known as exact once in order delivery, utilizing the conversation identifier and sequence numbers or queuing order internally in Service Broker. There's always two participants, an initiator and a target. They can be the same service though. But as far as Service Broker is considered, the service is initiating a conversation that targets itself. Or the service initiates a conversation that targets another service implemented inside of Service Broker. And then our messages for that conversation or dialogue are what exchange our information. So to process messages, I said earlier, we have to use the receive DML command. It can be used to process three different ways. One, a single message using top one. This is the slowest message, but it's also the most commonly implemented because it's the easiest to get right. Or we can receive all messages for a single conversation utilizing a table variable. That can be faster because you using a cursor to iterate that table variable is actually more efficient than having to lock and unlock messages on the queue and write the transaction log entries for dequeuing a message that allows crash recovery to put the message back on the queue if there's a failure and the transaction doesn't commit. Or if you're using conversation grouping, which is you create a group of different conversation handles that are related to the same task, you can retrieve all of those grouped messages together as well, which is also a pretty fast way of doing things. But regardless of how you do it, messages are always going to be received in the sequence order by conversation. When you issue the receive command, the best practices for implementation would be to receive inside of an open transaction. That way, if there's a failure for any reason, the transaction rolls back, the messages go back on the queue, and nothing is lost. If you issue receive outside of a transaction, then any failure, the message is gone. It's not going to go back onto the queue. So this can be a bottleneck if you use a single conversation for every message that you send inside of the system. You can also have a bottleneck creating conversations as well. That's probably one of the most expensive operations, is creating and tearing down conversations in Service Broker. So there's a great white paper by the CAT team that talks about what's known as the 150 trick that alleviates some of the contention on high throughput systems. That's kind of beyond the purposes of this session, but if you're interested in like high throughput scalability with Service Broker, the 150 implementation or trick is something you definitely want to look at. There's example code for it in the CAT team paper, and Remus Rusanu, Rusanu, who worked on the Microsoft team that built Service Broker years ago, has a great blog post that talks about how to implement that appropriately as well. So you want to use transactions, like I said, when you process messages. You also want to implement error handling so that you don't get what's known as a poison message, which is going to be a message that's unprocessable without failing and causes a rollback. And if the message fails 5 times sequentially, the queue that has activation enabled on it will actually go into a disabled state to stop the application from looping in an infinite loop of failure. So every conversation you create for sending messages generates a unique conversation handle, and that conversation handle gets created by the initiating service when you execute the begin dialog conversation command. You have to store that conversation handle anytime you deal with a message in Service Broker, because you have to utilize that to send any response messages back and to end the conversation and cause it to clean up inside of the system. So anytime you'll see in the demos, anytime that we're grabbing or receiving a message from a queue, we also receive the message type and the conversation handle associated with it as a minimum, because those are our 2 things that we're going to need to be able to respond. Now, some interactions require a back and forth series of messages. When that happens, a lot of times the best implementation to make sure that you're cleaning up the conversation appropriately and not creating orphan transactions or orphan dialogues in the system is to utilize what's known as an end of stream message. And the end of stream message is basically an empty message that says, this is the last message coming. And when that's received from either side of the conversation, it knows to end that conversation and clean up. And Remus Rusanu has a great blog post that talks about fire and forget architectures that they work until they just don't, usually because of a change in application design. Fire and forget is basically we're going to send a message and then close the conversation. For a lot of reasons, that's not a good implementation. Even if you're never going to use that conversation again, implement the end conversation or end of stream that sends back as a means of the target saying, all right, I've processed that message and now I'm going to end it. Because if there's some kind of a delay in routing or forwarding of a message or something else, and the target service receives the end conversation from the initiator before the message, that message that comes through is now an error case and will be invalid, and it can create problems. It's kind of rare for that to happen, but when you get into some of the really complex architectures that have what are called forwarding servers or load balancing of messages, it can happen, and it creates some challenges. So a basic example for sending or creating a conversation would be sending a request by beginning a dialogue. And then as a part of that, we're going to specify the initiator service name, the target service name, and the contract. That's going to return a conversation handle to us, or that unique identifier for the conversation. Then we're going to specify that conversation handle, the message to be sent, and the message type when we execute send on conversation. That's going to send the message to our target service, and then our target service will queue that into its queue. Once it's in the queue, we receive the message, process it, and then end the conversation. Or I'm sorry, we receive the message, send a response from the target back to the initiator, and as a part of that, we're going to use the same conversation handle, specify the appropriate message type, and then the message body to be sent. And then the last thing would be to receive that message that was the reply. So in our demo case, we're going to send a request message, we're going to read it, and then we're going to send a reply message back. We're going to receive that reply, and then we're going to end the conversation, which is what sends our system in dialogue message along. And that in dialogue says, no more activity is coming. This conversation is closed. So let's create a send request. So I get this question periodically, and I'll just address it ahead of time. Do you need a transaction to create a dialogue and send a message? No, you don't. We could comment this out. It's in almost every example that's out there. A lot of my example code that I've had for years still has it in it because I just haven't gone through all of these script files and cleaned it out. But I could delete this line and delete this commit transaction, and it's going to function just the same. So don't think that that's a part of the model. Some of the other implementations where I use a wrapper store procedure called USP send to send service broker messages, there's a reason there's a transaction or a dialogue handle, or yeah, I said it right the first time, a transaction as a part of that code, because it's actually doing other tasks along the way to sending that message. So if we just execute this, we're going to create a dialogue handle variable that's a unique identifier. We're going to begin a dialogue and store that handle from our initiator service to our target service, specifying our sample contract. We're going to build just a basic request message, and then we're going to send that using our dialogue handle or conversation handle we created. It's going to be a request message type, and here's our message body. So let's send that message. And if we look at our conversation groups view, we'll see that we have two handles here. One from our initiator service, one to our target service. So if we query our target queue now, and this is just kind of peeking at the queue. We're not taking anything off of it. We're not processing anything. We're just looking at it. So if we look at our target queue, we'll see we have a message for our target service on our sample contract, it's a request message, and here's our message body, which is the binary value or representation. It also tells us that it was validated as XML. So we can cast that message to XML and view our request message that was sent. It also tells us what time that message entered the queue. And if we scroll back over, here's our message sequence number and our queuing order. So if I were to fire this again, and we go look at our queue, this was queued in order 01, but notice they have different sequence numbers. The reason being they have different conversation handles. So they're part of different conversation groups. They have different handles. This is message 0 of this conversation. This is message 0 of this conversation. And they both have the same body. So what we're going to do is process that request. Now here we want to have a transaction. We're going to get our conversation handle, our message body, and the message type name from our queue. So we're going to take the first message off the queue. We're going to just select the message out so we can view it. If the message is a request message, we're going to generate a reply and we're going to send it back on our conversation handle, specifying the reply message type. So let's execute this. So we got our request message. We sent a reply back. If we check our target queue, our first message is gone. And if we check our initiator queue, here's our reply message. So conversation handle, the sequence number is specific to this handle within this queue. It validates as XML. It is a reply message, and here is what was received. So let's handle that one more time just to clear the target queue. And we should have 2 reply messages sitting in our initiator queue, and we do. So target queue is empty, initiator queue has 2 replies. So what we're going to do is we're going to process from our initiator queue now the same 3 items. If it's a reply message, we're just going to end the conversation to cause it to clean up and return our reply message back out. So now if we look at our target queue, we'll see we have another message, queue order 2, and now it's at sequence number 1, meaning that it's the second message in this conversation for this conversation handle that arrived on this queue. Our message type here is a in dialog message, and it validates that it's an empty message. And all this says a system message type that says clean up this conversation. You have to do this or your database will grow infinitely until you go clear all the conversation handles. This is probably the #1 error or mistake I see people make with Service Broker. And it usually comes as a question, my database is taking up lots of space and I can't figure out where. Or it's an internal queue table that's utilizing all of the space. How do I fix it? And a lot of people will answer, in conversation with cleanup or alter database, set new broker. They do things that are basically like the sledgehammer approach to clearing this out and removing the issue. And you have no idea what you actually lost when you implement one of those. So be very careful with that kind of advice. Usually I would just tell you to put a cursor in place that goes and looks for conversation handles that are old and haven't had anything sent on them in a long time, and just start cleaning those out. And over time, you'll correct the issue. I've seen databases that have multiple millions of conversation handles that have been leaked because nobody implemented an in dialog or in conversation component to the application. So if we clear the other one out, now we check our queues. Whoops, wrong button again. And we have queue order 2, 3, message sequence number 1, both are in dialog. So we need to handle those on our target side. So we're going to receive our message. If it's an in dialog message, we're just going to clean up our side and tell it to end the conversation. So let's run that twice. And if we check our queues, they'll both be empty now. And if we check our conversation groups, they've all been cleared out. So that's kind of an end-to-end interaction. It's really easy to implement when you know all the components and all the commands that need to be run, right? But if you had to look at demos that talk about all of these different pieces, it really is hard to put a cohesive implementation together out of just the books online or even some of the blog posts. It's something I've had a problem blogging about or providing implementations that aren't just this massive script that does everything. Because if you get out of sequence or out of order just once, it doesn't work correctly. So it can be, I always say it's kind of a bear to get your arms around at first, but once you have it going and once you understand the basics, it's really not that hard to implement or to have a functional environment for. So dialogue conversation internals. The delivery of a message from one service to another is not considered complete until an acknowledgement of receipt has been received from the target or the service that's receiving the message. Any outgoing messages are queued internally in the database in what's known as the transmission queue until they're acknowledged by the target service. If a service is unavailable for any reason, the messages remain in the transmission queue. What makes a service unavailable? For Service Broker, all it means is that it did not get that acknowledgement message back of receipt. That to Service Broker says this message has not been acknowledged, it hasn't been received, keep it in the transmission queue, retry sending it again every minute until it either ends, the lifetime expires, or you manually execute a cleanup of that. Radu asks, is the end conversation to be sent by the initiator or by the target? It depends. There's not a single answer solution for who initiates the end of the conversation. If there is a back and forth sequence of messages, I always implement what I call an end of stream as a final message. And whoever gets the end of stream message is who calls in conversation first. Then the in dialog message is sent to the other service and you just end conversation when you process the in dialog message. It can be implemented either way, right? The target, usually if you're doing what would be considered fire and forget, where you send one message and it executes an asynchronous task and you never send a response back, then I implement in conversation as a part of that task processing. So the target would implement that. If there's supposed to be a response sent back, then the initiator might be the one that implements in conversation. It really depends on what your needs are. There's not a single solution there. Activation is what allows for automated processing internally in SQL Server. Almost everything I do with Service Broker has some kind of activation built on it. We might disable queue activation during certain times of the day or outside of certain operations, and then we enable it by a job or some other task. But there's always a activation process or processor that is built in to handle the messages. If you're building applications in the database, it's a stored procedure. One of the great things about utilizing stored procedures is it's all T-SQL code. One of the bad things about utilizing stored procedures is it's all T-SQL code. And certain processes or tasks aren't really driven towards the serial execution or implementation with good performance inside of SQL Server. Things like XML processing. If you have really, really large XML documents, a lot of times .NET code can handle those much more efficiently. If you're trying to send information to a web service. A lot of times that's better implemented outside of the database engine instead of trying to use an unsafe SQL CLR implementation or something like that. So the store procedure gets associated with the queue. It starts automatically. It has to have an owner and use execute as for security context. And if you plan on crossing database boundaries, you need to use certificate signing. You can also do activation outside of the database through an application or service that monitors the queue. The external activation feature is the easiest way to get that configured because it handles all the monitoring of the queue, and it's actually what just executes your executable for your application. And the application just needs to know how to receive the messages and then do the processing. When asked, are there any Windows services that run Service Broker? Not natively. There are third-party applications that implement services on top of Service Broker. The database mail executable as a part of the SQL Server engine uses it. You can write a service that will monitor the queue, or that can wake up on queue activation as well. There's a number of ways to do that. Can the activation be done in CLR? You can use a CLR stored procedure and bind that stored procedure to a queue and use SQL CLR for processing the queue messages. Absolutely. Depending on the use case, you might as well take that code outside of the application because you would be writing the same code as an executable that would process the queue as you would as a CLR procedure. And if you need to do anything that would require external access or unsafe assembly, I would just tell you to do it outside of the database and let it scale there instead of using the SQL Server resources. Because there's all kinds of interesting things you can run into with CLR assemblies with availability groups and some of the other features sometimes. So if we're going to build an activation demo or procedure, so we're going to build a procedure to process our activation or target queue. Usually I name these whatever the queue name is _ activation procedure. So if you ever see that name, it might be something that's just based on a demo. I do that because I like really purposefully named items so that when I'm looking for something, it's very easy to figure out. So we're going to run a while loop that lets this run infinitely. And essentially, as long as there's a message on the queue and we haven't reached our timeout receiving one, which is 5 seconds, then we'll allow this to keep processing messages. And this keeps the queue processor live until there's no reason for it to be running. So the timeout's 5 seconds. If we don't get anything in 5 seconds, it bails out of this receive, and then it checks the row count. If we got nothing, roll back the transaction and break out of the queue, causing the procedure to exit. If we get a message, then we're going to check, is it a request message? If it is, build our reply and send the reply back on our conversation handle. If it's not a request message, is it an in dialog system message? If it is, we need to clean up that conversation handle, so clean it up. If it's not a request or in dialog message, is it an error in Service Broker? If it is, parse the XML out, raise an error with log to log it to the error log, and then end the conversation handle to clean it up. Because once there's a dialogue error within the conversation, that conversation can no longer be used. So we're just going to go clean that up. And then finally, commit the transaction. This note is here intentionally. When you implement an activation store procedure, always test it manually before you bind it to a queue. If you don't, you can end up with the queue activating and failing and then going into a disabled state. So what we're going to do is we're going to send our same request message along. Look at our conversation groups. We have our 2 handles. Look at our target queue. We have a message, nothing on our initiator queue. So we're going to execute our stored procedure to test it, and it'll sit. It takes 5 seconds for it to time out. And when it's timed out, we can go check our queues. And our target queue no longer has a message. We have a reply waiting in our initiator queue. So we're going to handle our reply message and end the conversation. Check our queues. Now our target queue has our in dialog message. So we need to test that as well. So we're going to execute our stored procedure and check our queues. And now everything is handled. It cleaned up our in dialog message. It closed our conversation handle out. So to automate the activation of our target queue, we're going to alter the queue, specify activation as on, our target queue activation procedure, and then max queue readers is how many concurrent executions can be running based on our volume of message receipt. So right now it's 10. Usually I restrict that back to like 4 to start out with, and then bump it up as I need to based on the load of the system. Four queue activation processes can actually do a decent amount. So what we're going to do is we're going to generate a new request. We're going to send it, and then we're going to check our queues. So we sent our request message. Here's our conversation handles. This is our target queue. It's empty. Why? Because it's already processed that request, and here's our reply. And the time it took to send that request and then query the DMVs, it had already fired and handled it internally. So we're going to test the automation by receiving that message and sending our in conversation, and then checking our queues. And again, it's already handled the message and cleaned up, and the in dialog was already taken care of by the time we go query the queue. So if we wanted to automate it end to end, we need to create a separate activation procedure that handles the initiator queue side. So the only difference here is if it's a reply message, we're going to end the conversation, and then we're going to bind that procedure to our initiator queue for automated activation. Everything else, I'm sorry, it's also coming from the initiator queue. But this is the basic pattern, and I start with essentially this model or this copy of code every time I implement Service Broker. The only thing that I'm changing is the name of the queue, the message type, and I might have additional message types, but for that message, whatever needs to be processed, and then I always have these same blocks of code for handling our system messages as required. So let's execute that. And we're going to wrap up by verifying end-to-end dialog activation. So we're going to send a message, check our conversation groups, check our queues. And by the time we query, everything is cleared. Service Broker is very efficient at being able to process queued messages and queued requests when they come through. So with that, that's the basic architecture for Service Broker. Are there any additional questions related to anything that I've talked about?
Hey, Jonathan, it looks like you've managed to catch everything that we had in the queue. If anybody's got any extra questions, go ahead and type them into the question pane now.
And if there aren't questions, then I would say thanks for attending. And that should actually be white. I don't know what happened when I copied that slide over. The demos and the scripts are available on the SQL Skills website. So if you go to https://www.sqlskills.com, and I specify the S intentionally there. Right now, we're having an issue with our URL rewrite rule not firing correctly. If you put in HTTP, it doesn't redirect you to our SSL site appropriately, and I'm trying to troubleshoot that. But if you go to the resources page, There will be a link to download there, and I'll also send them over to the organizers of this virtual group as well, so that they can provide it.
Yeah, I'll when I get the recording posted tonight, I'll make sure to include a link in the email that I send out to everybody. I think that's it. Thank you very much, Jonathan. I appreciate it.
Sure.
Thanks everybody for joining us. Keep an eye out for an email when I get the recording published, and we'll see you all next time. Thanks a lot.
All right. Bye.
Bye-bye.